Okay, so looking on page 2 of our notes from section 11.2, we see at the top I've given you some of the key formulas for finding a particular term. Starting with the first term, we could find that term if we know the number of terms and the common difference. Here we know the sum of the first n terms is n over 2 times the sum of the first and the last term. If we don't know this last term, this is the last formula we developed in the other page, this form's useful if we don't know the last term. And so in that case, in example 6, that's the actual case that we're talking about here. So we want to find the sum of the first 21 terms. We're given the first 4 terms. This formula works nicely, and so we do S sub 21, the sum of the first 21 terms, and that is equal to 21 terms divided by 2, and then 2 times the first term is 48, plus then n minus 1, n is 21, so 21 minus 1, or 20, and then times the common difference. Well, we need to figure out what the common difference. The common difference, you can see if we go from term to term, we are subtracting 4 every time, so the common difference would be negative 4. All right, and so if we calculate that, the total sum of the first 21 terms will be 168. Now, this formula is sort of a new one to me. This book uses it. My previous book did not use it. So I tend to just go back and use this form every time. So if I was going to do it this way, I would first have to, as an alternative, first have to find the 21st term using this formula here, the explicit formula. And so that would just be 48 plus 21 minus 1, or 20, times the common difference of negative 4. And so the 21st term, if we were to continue this sequence on and on and on, the 21st term would be negative 32. Now, knowing that term, we can go back and use this formula for the total sum. The sum of the first 21 terms would then be 21 over 2, the first term 48, plus the negative 32, and that again would give us the 168. So either way, you get the same value. This one, of course, is a little faster, but that just means one more formula to memorize. Quite honestly, I've never really used this formula very much. I usually just rely on this formula. It does include one extra step, however. Okay, so the next one, find the sum of the first 200 positive integers. And so if we write these out, that would be like 1 plus 2 plus 3 plus ... and going up to 198 plus 199 plus 200, and then adding all those up. So this one really is, this formula is the easiest one. And this is just that idea of we use the first and the last term. Notice that that will be the same as the second and the second to last term added up. So the sum of the first 200 terms is simply the number of terms divided by 2. So that tells us how many pairs we have, really. And then times 1 plus the 200. And so that gives us a total of 20,100. Okay. Next one, number 8. Find the sum of the first 15 terms of the arithmetic sequence. So the sum of the first 15 terms of the arithmetic sequence is 345. So this time we know the sum, and they want us to find the first term and the common difference. Now we also know some arbitrary term in between there. And we know the last term. And so then we take S sub n, S of 15, and so that's equal to 345. And we know A sub 15 equals 65. And so if we try to put that into our formula, we would know that the sum 345 is equal to, and then we know the number of sums is 15, and we know, and we have divide that by 2, and that's a sub 1 plus a sub n. Well, a sub n for us is a sub 15, which is just our 65. And so we could take this formula and solve it for, we would multiply both sides by 2 and divide both sides by 15, and then we would subtract 65. So the first term, a sub 1, is negative 19. All right, so we found that. Now we need to find the common difference, and so we can use this formula up here for that. We have a sub 15 equals a sub 1 plus, and then the difference in those is 14d. All right, so we just need to solve this for d. We know a sub 15, we know a sub 1. A sub 15 was given to us, that's 65. We found a sub 1, that's negative 19, plus 14d. So we just need to solve this for d. D ends up being 6, okay? All right, so arithmetic sequence. So we're going to look at the arithmetic sequences now using summation notations. Adjust that a little bit. Okay, so the general formula, I goes from 1 to n of d times I plus c. Well, this is going to generate, the first term this is going to generate is, when we put a 1 in here, it's d plus c would be the first term, and so on. So a sub 1 will just be d plus c, all right, in this case. And that's kind of what this is just saying here. So evaluate each sum. So we want to think about, well, what would the first term be? The first term is just going to be, if I put a 1 in here, it's just going to be 1, because 4 minus 3 is 1. And then what we can do is think, okay, what would the last term be? The last term would be using a 12 in here. And so then we would get negative 32 for the last term. So we could use this approach using our formula, and so that would give us s sub 12 would simply be 12 over 2, 1 minus 32, and so that gives us a grand total of negative 186. Now, because we're starting with 1 in this problem, we could break this problem up, and like we did in section 11.1, I from 1 to 12 of 4 minus 3 times the summation from I equals 1 to 12 of k. And we could break it up using that approach. Because this is arithmetic, though, it really is just faster to use this approach. Okay? All right. Just trying to focus that a little better. Okay, so the next one, in this case, we can't use the formulas like we did here because this doesn't start at 1, this one starts at 4. And so really what we want to do is plug a 4 into this. When we plug a 4 into this, we get 16 minus 6 is 10, and then we don't have to write them all out. We really just want to use the 18 now last, and so that gives us a value of 66. So we really just need the first and last terms in order to use our formula. So the sum of all of those, and I'm just using the generic n here because it's really not 18. 18 would imply that it's the first 18 terms, but we're not starting with 1, so I'm just going to use the generics s sub n here. And that's going to be, well, how many terms? Well, let's make sure we figure this out. So number of terms, it's the top number 18 minus the bottom number 4 plus 1. So that's 15 terms that we have. So if we were to write all of these out, we'd have 15 of them. So it's 15 is the total number of terms divided by 2, and then the first plus the last. And so that gives us 570 as the sum. Okay. So on example 10, they're asking us to write this series out using sigma notation. So we're sort of going in reverse. Here we started with sigma and we tried to find the sum. Here they're giving us the summation, and then we want to in turn write it with using a sigma notation. So we need to know how many terms we have, right? Because that's going to help us determine this number up on top. So we know the first term, the second, the third, the fourth, and then we know the last term. So we know this 35, we know it's a sub n, we just don't know what n is. And so we need to find that. The common difference, we can check that. That's clearly going to be 3, right? Each term, I would add 3 to get the next term. So the common difference is 3. And so we want to know what term this is. So let's go ahead and plug that into our formula. So a sub m equals a sub 1, which is 2, plus, and then n minus 1 times the difference, and we just found that the difference is 3. So in this formula, we could solve this for n. We simply are going to do what? Subtract 2 first. We get 33 equals n minus 1 times 3. We divide both sides by 3. 11 is equal to n minus 1. And then we simply add 1. So n is equal to 12. So we know that this thing really is a sub 12. So we know a sub 12 is equal to 35. Okay. So now we just got to write our sigma notation. And we start with I from 1 to 12. And then the common difference, we know if we look at this up here, right, the common difference is the coefficient of our I. And so we have 3i. And then we have to think about when we put a 1 in here the very first time, we want to get a 2. And so what do we have to subtract from this in this case? We have to subtract 1. So it takes a little iterative process here to say, well, when I put a 1 in here, I'm going to get a 3. I don't want the first term to be a 3. I need the first term to be a 2. And so what would I have to do to that term to get it to be right? I would subtract 1. Now, so this is perfectly good. And we should double check that. If I increase by 1, I now will be 2. When I plug that in here, I get 6 minus 1, which is 5. So checking it for a couple things is good just to make sure, that we're doing it correctly. And so that would be a perfectly good answer. Now, another way that you can do this is you don't have to start with 1. We could, and this is how I prefer to do it actually, I could start with 0. But if I start with 0, I'm not going up to 12 anymore. If I start, instead of starting at 1, I start at 0, then I'm going to be going up to 11. And what's nice about starting with this one is that then I can just do 3i. Now when I put my first value of 0 in, this part goes away. And so this is nice because now the constant that I would add is simply a sub 1. So this is a little bit easier way to think of it. You don't have to figure out what this constant is. We know the constant in this case will be 2 because the very first value makes this a 0. So this is like the y-intercept almost, because when I put a 1 value of 0 in here, that term kind of goes away. So that's either one of those is acceptable. So let's try this next one. So they tell us, instead of giving us the sequence of numbers, they tell us what the fourth term is, they tell us what D is, they tell us the total number of terms in this case. So to start with, I know I can do I from 1 to 17, can definitely do that. And I know a difference of 3, so I know I'm going to have a 3i. I just don't know what this other thing is going to be. And so I kind of have to go back and find a sub 1. So I need a sub 1, so I know what to do to this to make it into the first term. So I'm going to use this in our formula. So we're going to do a sub 4 equals a sub 1 plus 4 minus 1 times our D. And so let's plug in what we know. Negative 15 is equal to a sub 1 plus 3 times our d, which is also 3. And so a sub 1 ends up being negative 24. So now looking at this value here, when I put a 1 in for this, I need this whole thing to be equal to negative 24. So this actually has to be negative 27. Because when I put a 1 in, that's going to be 3. 3 minus 27 is 24. Now, again, that's perfectly acceptable, but it takes a little bit of work to figure out what this number is in conjunction with the first value of I that we plug in there. So I find that these are easier to do if I use an I value of 0. So remember, I value of 0 means that this should be 1 less, so this will be 16 up here. All right, and then it's much simpler. I have 3i minus the first term, which is negative 24. So 3i plus a negative 24. This one's a little bit nicer because when you put a 0 in for I, this term goes away, and so the constant will just be the very first term. Oh, this is a sub 1 here. So the very first term will just be in here. So starting at 0, I find a little bit more straightforward, a little bit easier to do. All right, so your homework is listed here at the bottom. Make sure that you work on that and get it turned in.